Alright everyone, welcome back to the day 43 of our daily leetcode challenge, and today we have got max sum of pair with equal sum of digits. So if you read all this might appear a little confusing, but what they are asking us to do is you need to find two numbers in this nums list. Find two numbers num1 and num2 such that the sum of their digits is same. That's condition 1, that the sum of the digits must be same. That's condition 1, and the condition 2 is you have to return the sum of any two such numbers such that their digit sum is the same, and you need to find the maximum sum. So let's try to do a quick dry run on this input 1, which is example 1. You see the output coming is 54. If you take a look, the pairs that they have chosen for this answer is 0 and 2, meaning the value at index 0 and the value at index 2. If you take a look, you have 8 plus 1 as 9 and 3 plus 6 as 9. So the numbers 18 and 36, the sum of their digits is same, which is 9 in both the cases. Their sum of digits is same. So that's condition 1. And the other thing is that their sum, if you do that, it's going to be 54, and 54 turns out to be the maximum sum which is possible following these conditions. The condition 1 is, this is basically the two only condition which you have to take a look at this example, which is the sum of the digits should be same, and you need to find all such numbers in which all such pair of number, or you could say any two numbers in which the digits are sum of the digits is same, and if that's the case, what is the maximum sum that you can obtain if that condition is true. So this is what is happening. You need to find numbers such that the digits sum is same, and then also what would be the maximum sum possible by doing so. So the same thing is happening, and if that's if however, if there is a case where the condition where you need to find numbers where the sum is same, like let's say I have 5 numbers in the list, as 1 2 3 4 5. So if you try to take a look all these numbers, the sum of their digits is going to be 1 2 3 4 5 as it is. So in this case we are not finding any two or more than two numbers such that the sum is same. So if we can't even find numbers in which the sum is same, be it two numbers or three numbers or any such numbers in which the sum is same, we can't even do anything. So in those cases we just have to return -1. So let's see how we can solve this using some kind of algorithm, and how we can use hash maps or max heap maybe also can be used in this problem to solve this. So first, the first case that we need to make sure is that the given condition that we need to keep in mind is that the sum of the digits must be same. So what if there was a way to group all the numbers in this nums according to the sum of their digits. What I mean by that is, we go through each of these nums in the list which they have provided, find the sum of their digits and group them according to the sum in which they belong. What I mean by that is, if you take a look in this case, we are at 18 at the moment. Let's do the dry run on the first example that they have provided, which is 18, 43, 36, 13 and 7. We go number by number, find the sum of these digits and group all the numbers group all the numbers which have the same digit sum. So what I mean by that is, 1 and 8, we have 18 here, 1 and 8, the sum is 9. So I create a group called 9 and put 18 in it. Then we have 43, sum of the digits is 7. So I create a group called 7 and put 43 in it. Then we move to the next number, which is 36, sum of the digits is 9. So I'll put it in the group called 9, since the sum of its digits is 9. So I put it in this group. Then we come to 13, sum of the digits is 14. So I create a group called 4 and put 13 in it. The sum of 13, sum of digits is 4. Then we come to 7, the sum of digits is only 7. So we will put it in this group 7. 7 belongs to this group right here. Now in this case we are getting groups as 9, 7 and 4. Now out of all these groups that we have got, 4 has to be deleted, because in order to even consider 4 as a sum, you will need at least 2 or more, right? Because otherwise we can't even find other numbers. We need at least 2 numbers or more than that, such that the sum of their digits is same, and then only then we can find the sum of such numbers. So like the minimum criteria is the digits sum should be same, and the numbers for which the sum of the digits is same should be more than 1. So if that's not the case, we can just forget about this test case, just force sum right here, because there's no point considering it. Because had there been other numbers like 22, only then we could have sum 13 and 22 to even consider their sum as one of the candidates of the maximum sum that we need to find. we need to find the maximum sum of these numbers that we have right here. We have to find the maximum sum of these numbers that we have in this list. Since it's only 13 right now, we can't sum 13 with any other number. So that is why in this case we have to kind of forget about this sum that we have. So we delete this. Now we are left with 9 and 7. In 9, if you see, our possible candidates are 18 and 36, and in 7 we have 43 and 7. Now there could be multiple numbers as well. We could have this list could have been longer, and we could have more numbers like x, y, z in the case such that the digits in x, digits in y, digits in z, all these sum to 9, and more numbers in the case of 7 as well, like a, b and c, such that the sum of all the digits in a, b or c will also be 7. Now what we need to do is we need to select any two candidates from this list and two candidates from this list, such that we are maximizing the sum, because we in the end our goal is to find the maximum sum of those numbers such that their digits is same. So far we have solved the first criteria, which is the digits sum should be same. This list right here provides a list of all the numbers for which the digit sum is same. We have 9 here, 9 here, so with the case of x, y, z. Now we need to kind of maximize the sum that we are getting by any two numbers. We have to take any two numbers from here and any two numbers from here, such that the sum is maximum. Now since we need to maximize the sum, so we should always choose the two maximum values from this list that's gonna form. Any two numbers we pick, but they should be the greatest and the second greatest. The greatest and the second greatest if we get from this case and this case, since we don't know these numbers, so let's take greatest and the second greatest as these 36 and 18, and in this case the greatest and the second greatest would be 43 and 7. To find the greatest and the second greatest, we can actually do maximum and minimum, all that, but it's better to do something called as use of heaps. So with the help of heaps, we can convert this entire list to a heap and pop values from this heap. We'll just pop two values. So you know how a heap works. What it does is it puts maximum value at the top, that just like you see in a heap. So in Python, there's no concept of max heap but only a min heap. So you'll see how we can modify this value in favor of min heap and then get the value. So what we can do is, since we know that heap always provides us the bigger value of the minimum value, so a max heap will always provide since this is a min heap, the minimum value will always stay at the top, so this will give us a minimum value, but the max heap is just this heap inverted. It will always give you the maximum value. Since Python doesn't have a max heap and it only has a min heap, what we can do is, to get the maximum value, we can convert all these values to a negative, then in this case the maximum value earlier will now become the lowest value because of the minus sign, and now when we operate min heap, it will always give us the least value and the second least value, and then once we get that, we can again convert that from a negative value to a positive value and get our answer. So this is how we modify a min heap. Like we use the Python's min heap as a max heap by converting all its values to negative and then popping values from the heap that we made. So the step one will be to convert this list that we have all its value to a negative, and then from that negative values we convert this to a heap, which can be done using the heapify method that Python provides. Once that is done, we can pop two values from this heap, and those two values will be the least and the second least. Once we have that, we again convert that minus values to plus values by multiplying them with -1, and then once we have that, it will be nothing but the greatest and the second greatest values. So I hope you are getting this, because that's how we will be converting this list to a minus values and then back to a heap, and then again pop two values from this list and then find their sum. So if we do that, in this case it will be 54, and this case it will be 50. Eventually we'll just return the maximum value that we find. So this is what we're gonna do with each passing value in the nums. What we're gonna do is, step one will be to find the sum of all its digits, and once we have that, we create a group of that sum and add that value to that digit. Later, if we find more values with that sum, we'll put those values in that group. Once we are done with the grouping part, what will we end up having with is a hash map. This is nothing but a hash map, in which we're gonna use default dict. Default dict, I'm meaning the key will be the sum and the value will be all those values for which the digits value is nothing but the sum. So the value will be a list, and in this list we'll be adding all such digits for all such numbers for which the digit sum is equal to the key. The key here will be the sum value. In this case it's 9. We are adding all the numbers for which the digit sum is equal to this key right here. So once we add that, we'll take and also we need to delete all such key value pairs in which the value list is just 1. because we know we need at least two values so that we can pop the greatest and the second greatest from this longer list that we have. If the digits, if the only possible value in this list is just one, there's no need, we can't even pair it with any other value, so we just delete such values. It will help us with the better iteration and kind of reduce our space complexity. Once we are done with that, we'll only consider values for which the list value is more than 2, and once we have that, create a heap out of it, create a min heap, pop two values, convert them from a minus to a plus, and then add it, and then eventually find the maximum sum that we can get. And the reason we are popping two maximum values, because we are being greedy. We want to be greedy, we want to maximize the sum. Like if you tell me to find the maximum sum that is possible of any two numbers from this list, I will always choose the maximum and the second maximum value, because only then we are going to get the maximum sum which is possible of any two values. If I tell you to take two values a and b from this list so that the sum is maximized, you will always choose as maximum and the second maximum. The same thing we are doing here also, but in the minimum manner, because max heap is not possible in Python. We convert all these values to a negative, pop the values which are the least and the second least, and then again convert back them to a positive. This is how the min heap is working in Python. Max heap doesn't exist in Python, so this is how we are using min heap. And once that is done, we just find the sum of those values and return the maximum that we found so far. So this is how the algorithm is going to work. Now let's try to quickly code this up. So as I said, first what I need is a hash map in which the value is nothing but an empty list. So that can be done using this thing right here. We need a hash map called default dict, and in this the value will be a list, default dict. Now we need to iterate for each value in nums. Now what we need to do is sum all the digits that is occurring in this value called num. So value called val. So what we can do is this sum val is equal to this. I'm going to use Python comprehension here. I'm going to explain you what I'm doing. So what is happening here is, initially what we are doing is converting this value, which is an integer, to a string first, and then using list comprehension, what we are doing is, let me convert it back to a list as well. So right now what I did is, first I converted this value, which is 18 right now, to a string. So now this 18 looks like this. Now I'm going to explain you how we are finding the sum of all the digits of the list that they have provided us initially. So initially we have this nums right here. So first value is 18. I take 18. This is an integer right now. This is an integer. I convert it to a string. This becomes this now, 18. As you can see, this str right here is converting it to a string. Once that is done, what I'm doing is converting this str to a list. So now this looks like this, 1 and 8. It will take each value in this string and put it as 1 value once I put a list around it. So now this is a list. Now what I'm doing is a list comprehension. What I'm doing is I'm converting back each of these characters, which is a character right now, each of this character back to an integer using this. Convert each of this I int I for I in this list that we have right here. For I in, this in is nothing but the list that we have converted right now, just right now, this list, 1 8. So now we are converting it back to an integer. So now this looks something like this, and then in the end I'm putting a sum around this bigger list that we've just formed, the sum around it. So this will just return a list, the sum of all these values. So this will be a 9. So we started with an 18 integer and we are returning a 9. This is nothing but the sum of all of the digits. This is how you use Python comprehension to quickly find the sum of all the values in this number 18. So this is what is happening. Using list comprehension, I got that. Now since we have this, what I need to do is, in this hash map that we have, for this sum value, I need to append this value as a value for this key. For this key, I have an empty list initially, and in that empty list, I will add this value. Hash map sum val is initially an empty list. In this empty list, I'm going to add this value, because for this value, the sum of its digits is sum val. So that can be done using the append method. Now I have appended that. So this operation will keep on happening, and then we'll end up with our hash map. So let me show to you how the hash map looks like. I'm returning a 0 right here so that doesn't give me an error. You can see the hash map how it looks. This will look exactly like I drew it before. It's gonna look something like this. This hash map that I drew here, 974, having all these values. So let's do that. Let me show it to you. For the first test case, the hash map looks like this. 9 has 18 and 36, 7 has 43 and 7, and 4 has 13. What does it mean? 9 has values 18 and 36 because 18 sum of digits is 9, 36 sum of digits is 9. For 7, the sum of digits is 7, 43 is 7, and 7 is again 7. For 4, 1 plus 3 is 4. Now, as I said, in this hash map, for each of the keys, we need at least 2 or more values. 2 or more values. If you see the key 4, it has only 1. So we need to delete all such keys. We can do that by quickly iterating this hash map. For each key in hash map, if hash map key, this hash map key is nothing but a list. If the length of this list that we are getting is equal to 1, this is how we're going to check. Then we need to basically delete that key from the hash map. That entire key value pair needs to be deleted. So this, what will happen is this extra key that we have, right, 4, 13, this will get deleted because we need more values. We need more values. Now that is done. Since any such keys are deleted for which the value is just 1, we are done with those deletions. Now what we can do is, let me just define a maximum variable called minus float infinity. Now it's time to do the heap part. So again, what we need to do is, for lists in hash map dot values, this hash map dot values is nothing but a list. This hash map dot values is nothing but a list of all such lists. 18, 36, 43, 7 is basically grouping all the values for this hash map after those deletions in which the values list was just 1. If you take a look in this hash map, the keys are the sum value and the values are nothing but a list. So this iteration that we are doing here, in this hash map dot values, this is going to be a list that's going to contain all such lists, 18, 36, 43, 7, and further many such lists for which the sum of the digits is equal to that key that it belongs to. So once we have those lists, what we need to do is, step 1 is to kind of use list comprehensions and convert all the values in this list to negative. So this can be again done using list comprehension. So we are now kind of renaming lists to list, in which we are creating a new list and renaming it to list back again, in which all the values in which this list is getting converted to a -1. Now since this is done, we need to convert this to a heap. This can be done using the heapify method in the heapq package. heapq.heapify lists. Now we have got this. Now we need to pop 2 values from this list. So val1 is equal to heapq.heap_pop lists. This is our heap. We just converted list now to a heap. This is not a list anymore. This is now a heap, and we have from this heap we are popping one value and then the second value, val2. Same thing. We need to pop 2 values as discussed to find the least and the second least. Since the values are all negative, we are getting the least and the second least. We are getting negative values. Now we need to convert them to a positive values and then find the sum. So this will be done using I need to just add a minus sign before this val1 and minus sign again on val2. Both these values will be negative initially. This minus sign will convert it back to a positive, so that the least and the second least value, again after putting them a minus on either side, will become the max and the second max. That's how we are becoming greedy and trying to maximize our sum. This is our sum val right here. Now once we have that, what I need to do is, I need to find the maximum between this sum val and the maximum that we have defined here, minus float infinity. So you need to update this maximum value. So maximum value will become max of max val and the sum val that we just got. This is how we find the maximum, and once we have that, we simply need to return the max val. Let's try to run this now. So this is how we are kind of iterating the hash map if you want to kind of get rid of that error that we were getting earlier. So it's better to convert this hash map dot keys to a list, get a list of all the keys, iterate through that list, and then modify the hash map. So if you do that, then you'll see you won't get that error, because if you try to loop a hash map while deleting keys in it, it will give you an error, meaning the dictionary size changed while you were iterating it. So to not do that, what you can do is convert the keys to a list, get a list of all the keys. This keys method give you all the keys in the hash map. Once you have that, loop on this list rather than looping on the hash map. And for each key in this list, if the length for that list for that key you are getting as equal to 1, it means you need to delete that from the hash map. So we are getting rid of all such values for which the list that we got was just 1. So like in the case that I showed you, 7 had just 1. Like in the case of 3 plus 1 4 just had 1. 7 had 2, 4 3 7 4 3 7, but in the case of 3 plus 1 13, it was just 9 in the group, so we had to get rid of 13 and 9 list. So if let's say, as I discussed, there was an example possible for which, let's say 1 2 3 4 5. For this case, the hash map that would be forming will look something like this. We'll have the sum of digits for 1 as 1, and for this one we'll just have 1 in it. For the case of 2, it will look like this. Same for 3, and same for 4, and same for 5 as well. All these pairs are to be deleted. All these pairs has to be deleted, because we know that for each sum that we got, we need at least 2 value in this list. Since there is only 1 value, so we'll be deleting that. In the end, after deleting each key value pair, we'll be left with an empty kind of, you could say, an empty hash map. When that is the case, we have no other option but to return a -1. So our indication to return a -1 would be only when we get an empty hash map. So after this line, you see our case 2 is getting returning null here, because in this case for 10 12 19 14, if you print the hash map before deleting, for the second case, if you print the hash map, you will see something. It's exactly the test case that I just discussed, 1 2 3 4 5. So see, for 1 and 10, like 1 and 0 10, the sum of digits is 1, and 10 is the only value which has the sum of digits as 1. Same for 12 as well, sum of digits is 3, and 12 is the only value which is having that. 1 and 9 is 10, 10 is the only 19 is the only number for which the sum of digits is 10. So all these key value pairs, the value is a list and the length is 1. So after we delete all these values, after we delete all these key value pairs, all these key value pairs, we're going to left with an empty hash map. And if that's the condition, we'll have to return a -1. So after this deletion that happens here at line 14, we need to do a small check, if not hash map. This becomes true if the hash map is empty, if not hash map. So since empty hash map is a false, two false become a true. This will get true only if hash map is empty, hence the not case. If that's the case, you simply need to return -1. And once you do that, you will see our second test case will also get satisfied. Let's try to run this now. As you can see, now it's satisfying both the test cases. This is the case where the sum of the digits is unique, meaning each number, for each number the sum of digits is this number alone. This number alone is the only number existing for this sum. So in that case, we have to return a -1, because the hash map will become empty. We got rid of all such key value pairs at which the value is a single length list. So this is the entire code for this question. Now let's try to submit this. So as you can see, it's satisfying the test cases, and that was it for today, everyone. I'll see you in the next one. Like and subscribe. Bye.